All right, I'll let you pause the video, read the context, but essentially what we need to do here is construct and interpret a 90% confidence interval for the difference in mean percent change between these two wines, a red wine and a white wine. So 90% confidence interval, these are means. So let's go ahead and start with our process. Our process, we always begin with a statement of what we're about to do and then include some specifics. So that statement looks like this. And it's really just a restatement of what they set up here and the directions. The next thing that we need to include is we want to define any notation or define the parameters that we're going to be talking about here. So here are my parameters and what they mean. So the first thing is just the population mean change in levels for red wine drinkers and population mean change in level for white wine drinkers. All right, next step in the process, we want to plan. So we want to check our conditions, make our plan for, make sure that the test that we want to run is that we actually can run it. So 3 conditions look like this. We've got number 1, we need the subjects to be randomly selected. Number 2, we need our sample to be less than 10% of the population in each of these cases. And number 3, we're looking for normal. So is it normal? So usually we check that to see if our samples are bigger than 30 for each one of those, or we can just look for normality. So number 1, this is a completely randomized design. It's an experiment. So because this is a completely randomized experiment, this one checks out. So we either need subjects to be randomly selected to build our samples, or we need to be running a randomized experiment. Less than 10%, same thing. We don't have a population here per se. We don't need less than 10% of the population, I should say, because it's completely randomized experiment. And the next one is this one here. So we're checking for normality, and the reason that we're checking for normality is because our samples are only 9. So we only have 9 subjects in this particular case. So we actually need these to be not necessarily normal, but we just need no heavy skew or outliers. So we need to plug this data into the Inspire and go ahead and check either a box plot or a histogram for no heavy skew and check for outliers. So let's go ahead and do that. So this is on the Inspire. I've already entered the data, but if you want to go ahead and just a quick review of how to do this, we hit Doc, we go over to Insert, and we want to insert a list or a spreadsheet so that we could enter this information. So you would go ahead and check that. That would give you a spreadsheet. And from there, you got to make sure that you name these cells. So we've got our data entered. Click up in the header there. We want column A. We're just going to go to Menu and Data and Quick Graph. That's the quickest way to get a graph here. And we want to make sure we've already got our red down here on the x-axis, but we want to make sure that we've got either a histogram or a box plot. We're going to do a box plot for this one. So you go to Menu, Plot Type, and we want to change this to a box plot here. So there's my box plot for that one. Looks like it's a bit skewed, but not too bad, and good enough so that we can have confidence that our sampling distribution is going to be relatively normal. So let's go ahead and do that for this one. This next one, the white wine. Oops, quick graph. There's my quick graph for the white wine. And again, change the plot type, go to box plot, and there's my box plot. And again, looks slightly skewed left, but no major skew. Doesn't look like any outliers according to this. So we should be good to go on this normality condition. So let's hop back here. Good to go here. So all of our conditions check out. And we can go ahead with a Two sample confidence interval for the difference in means. You don't have to write all this. You can just write two sample confidence interval. But that's what we're trying to find here. So a couple things that we have to specify. Number one, we want to specify what kind of confidence interval. So up here, you can either say two sample t interval, or you can just say two sample confidence interval and specify somewhere else that it's a t interval, or you're using the t distribution. Number two, if you're using a t interval, you got to make sure that you report what your critical t is, your t star. And you also, well, I guess in order to do this, you need the degrees of freedom. So this is the important information you want to make sure that you include, especially if you're using a calculator. If you're not using a calculator, you're doing everything by hand, you're going to include a lot more information than this. But we're going to use our Inspire to calculate this confidence interval. So let's go ahead and do this. Our degrees of freedom, two different ways that you can do it. Number one, you can look at your two samples. I know that the sample for red, the sample size was 9. The sample size for white was also 9. So we would take the lesser of these two. Obviously, for this example, it's easy. They're both the same. But in general, you're always taking the lesser of the two. So in this particular case, obviously, they're both the same. I've got my degrees of freedom are n minus 1 for the lesser of the two. I've got 8 degrees of freedom. The other way that we can do this is use the calculator. And I'll show you that how that sets up here in a little bit. We're going to use this 8 degrees of freedom to calculate our T star though. So in order to do that, in order to calculate our T star, we do need that degrees of freedom, but we also want to use that inverse T function. And that inverse T function is going to ask us for an area and the number and the degrees of freedom. So let's go over to our calculator. We're going to use that inverse T function. We're going to hit menu, statistics, and distributions. We want to use the T distribution, and I'm going to go over to inverse T. So here's my inverse T and the area that it's asking me for. Let's pop back here real quick. Remember, we're doing a 90% confidence interval, but the area that it's asking me for is this area right here, which would be half of what's left over in the tails. So this would be 0.05. So the area that we want to enter, 0.05. The degrees of freedom, we just used our conservative estimate of 8. And this should spit out our T star. So our T star, critical T value, negative 1.8596, or let's go negative 1.86. So we got that info. T star equals negative 1.86-ish, right around there. And now we've got everything that we need to go ahead and find our confidence interval. So back over to the calculator. We're going to hit menu, go back down to statistics, calculate a confidence interval. We want a 2 sample T interval. So here's our 2 sample T interval. And it asks us for data or stats. So we actually want to use the data and go ahead and enter our information. All right, so there's our info. Our first list was the red wine levels. Second list was the white wine levels. Frequencies obviously correspond with those. And then confidence level is 0.9. And it's asking us for pooled. Remember, we only use pooled when we're talking about tests for differences. So when we're talking about tests for differences, our null hypothesis is always that there is no difference. So we can pool the information together, pool our sample statistics together to make one sample statistic. But this is a confidence interval, so we're not going to do pooled. Okay, so all that's left is we're going to find our confidence interval here. It spits out a ton of information. And here's what I wanted to show you before. Remember degrees of freedom? We used 8 degrees of freedom. That's a more conservative distribution in terms of what we're calculating for this interval. The calculator uses a little bit different formula. So it's completely acceptable to use this. You just need to report that and say that you got it from the calculator. They're using a T distribution of 15 with 15 degrees of freedom. So it would give you a little different estimate there. All right. So on this interval, we've got the lower is 2.97. The upper is 7.77. All right. So I've got my confidence interval right there. And just keep in mind what we just found was the confidence interval for the true differences in means between red wine polyphenol levels for red wine drinkers and polyphenol uh, levels for white wine drinkers. So the last step is really to put that into context like we just did. So that looks like this. We're 90% confident the true mean difference in polyphenol levels in red wine drinkers and white wine drinkers is between 2.97 and 7.77%.